John A. Wheeler, in his article Beyond the End of Time, wrote, "Some principle uniquely right and uniquely simple must, when one knows it, be also so obvious that it is clear that the universe is built and must be built in such and such a way, and that it could not possibly be otherwise. This optimism that a sudden insight will illuminate all the secrets of the universe was shared by hundreds of scientists for many years." Contrast this with John A. Wheeler's last sentence in his more recent article, Time Today. "We have no compass and we have a more difficult voyage to accomplish because we lack any plan to find how come time, except to try to discover how come the quantum. Bon voyage." Engineers engaged in difficult troubleshooting tasks sometimes force bursts of insight with a tactic known as cause and effect reversal. What would happen if this tactic were applied in a brainstorming session to force the bursts of insight into the nature of time so long awaited by scientists? First, the subject would be hauled into the session and laid bare of its cloaks of previous assumptions. Like a patient on an operating table, parts essential to the problem would be exposed and bathed in bright new lights. A storm of scrutiny would seek out all present notions of cause and effect. These notions begin with the World Book Encyclopedia treatment of quantum mechanics that concludes, Einstein firmly established in his 1905 paper about the photoelectric effect that light consists of energy particles that have wave properties. Contrast this with Einstein's own words. He said, "What appears certain to me, however, is that in the foundations of any consistent field theory there shall not be, in addition to the concept of fields, any concept of particles." Could it be that we have become so entangled in the particle concept that we unconsciously distort observations of the past? Isaac Newton first theorized that light may be composed of particles in his 1604 work, Optics. James Clerk Maxwell showed that light was propagated through space by electric and magnetic change in 1864. In 1900, Max Planck used a small constant value he called quanta to explain blackbody radiation. 5 years later, Albert Einstein published a paper in which he used Planck's constant to describe the energy distribution of electrons emitted from metals when they were exposed to light. Einstein called these particles of light photons. This constant of Max Planck's was in units of erg seconds, or energy time. Thus, quantum mechanics was born. Planck and Einstein brought it into being, but there was a major problem that Einstein saw from the beginning. There was in the concept of particles with wave properties no clear concept of cause and effect. What was the cause of the wave properties of these particles? Einstein frequently put the question but never found the answer. There were clearly both wave properties and particle properties in light. Scientists knew that the waves undulated with time, giving a sinusoidal waveform that occupied space. They knew that the wave was transverse, like a water wave, and not longitudinal, like a sound wave. How could that wave shape derive from a single particle? It simply could not without distorting the concept of particle. This problem was compounded by the fact that the problem solvers were seldom the same people as the observers. It was as if one team of troubleshooters asked for symptoms, another team supplied the answers, and the answering team supplied incorrect results about 1/3 of the time. Will Rogers once said, "It ain't so much that people don't know, it's that people know so much that just ain't so." Our brainstorming session must consider this flaw of human experience. That's why the finely sewn and beautifully woven cloak of past assumptions was thrown aside. Being a product of human thought, it must contain many errors and misconceptions. After the session, participants will reinstall the cloak and mark suspicious patches for further study. Going in to the troubleshooting task to find the true nature of the quantum and time, our participants observe that the quantum is built only of time, space, and electromagnetic change. They might begin by asking observers, what if light were really a quantified wave instead of a wave-like particle? Now we have a wave that looks like a particle instead of a particle that looks like a wave. Being quantified by Planck's constant, the wave must exist in a moving local area at a constant electromagnetic amplitude. Our brainstorming scientists pounce on this new insight like a panther in a henhouse. New ideas fly like chickens knocked from the roost, but our big cat selects just one. Planck's constant is the unlucky bird. Our troubleshooters now begin to tear it apart. Planck's constant is 6.626075 times 10 to the minus 27th erg seconds. An erg is energy and a second is time. So Planck's constant is potential energy available over a period of time. It describes the potential work content of every photon. Since the only two variables that produce the constant are electromagnetic change and time, the electromagnetic amplitude reached by the change must be a constant also. This is a simple mathematical reality that has great impact upon the cause of gravity. A photon model would consist of a field of electric charge occupying a circular plane and a field of magnetic lines of force occupying a similar plane opposed from the electric plane by 90 degrees. Places where the two planes cross would naturally define points, and points would naturally be observed as particles. There is the cause and effect that Einstein could not find in the concept just reversed. A quantified wave can reasonably define particle-like points, but a single particle cannot reasonably define a wave shape. Time is the central thing about this photon model. Time brings it existence. It consists solely of electromagnetic change with time. Since each one of the fields must change with time to produce the other, in accord with Maxwell's equations and Planck's constant, they must necessarily cease to exist if time were stopped. Otherwise, new laws of nature must be invented to keep the photon in existence without electric and magnetic change. Thus, there was insight derived from reversal of cause and effect, but it's not a new and different law. It was there all the time. It was at the seat of Maxwell's equations that have existed for well over 100 years, but it was not obvious until cause and effect were reversed. The insight we found was Howcome the Quantum. We found the cause of Planck's constant. That cause is that photons must saturate. The E and B fields exist at the maximum possible amplitude that space can support.